median uses the same concept, but getting different locations in the data. So we said we start at 9:10. I think we are at the mark of 9:10. You're looking at your watches. Yes, so my part, I'll just do the introduction, and then we look at the measures of central tendency, that is the median, using and group data. And my colleague, Mr. Mburu, will take up on the part of grouped data. So I will do the introduction based on a group and grouped data. Then Mwalimu will cover the other part of grouped data. So looking at the numbers now, it seems we are almost 150. If we are ready, we can start? Can we start? Yes. Okay. So I've already displayed the topic as we are talking about it then. So we are looking at statistics 2, median and quartile. So let's go right away to the calculations. Let me clear this. And now we go to the definitions. So there we are, introduction. I said I'm just doing introduction, Mr. Mburu will do the rest. So as you can see there, we are saying the median is the median data value when the data is arranged in either ascending or descending order. The median is the middle data value when the data is arranged in either ascending or descending order. Keywords here, does not matter whether the data is in ascending order or is in descending order. We are just interested in the middle position. The median divides data set into 2 equal parts. Another term there that is important to realize. The median divides the data set into 2 equal parts. Then finally, the median is an average that is not influenced by those large numbers, what we call the extreme value. So we say, if I was to think of data like a line, and that line is marked from 0 maybe to 10, then we are told find the median. We're saying the median is the data value that will occupy the middle position. So you'll be having data sets. So for example, if I now came up with a number like 3 is a data set, 7 is a data set, and the 15 is a data set. And I'm asked, which one is the median? So the median is the data value that occupies the center part, just as shown there. The data value at the center is the median. So we are arranging data, and then we pick the one at the center, and we call it the median. Right, I think the numbers are growing. We're almost at 170. Hope we are moving on well. Mburu?
Yes, sir.
Good. So that's how we define the median. So let's look at some examples. Or let's move to the next slide and see what we have there. The next slide says median of ungrouped data. And I think that is what I want to cover. For those who are not here, Mr. Mburu will do the other one. So median of ungrouped data. For a data set of n numbers that are arranged in ascending order, the median is the value that occupies that position in the middle. So when we write this formula, because it's the formula we are going to build on, this one, it is the formula we're going to build on. But look at the key word. I'm not saying that is the median. I'm saying that is the position of the median. I have 3 data points. The way I had, I think 3, 7, and 15. And I want to know which data is at the center. I'll ask myself, what is n? N is the number of data points. Here I have 3 data points. So we're saying the median is n plus 1, and then I divide by 2. So 3 plus 1 gives me 4. 4 divided by 2 gives me second position. So the data that occupies the second position becomes the median. So whatever we are describing there is the position of the median, is not the median itself. However, there are some other key points here to note. For example, we are saying when n is an odd number, the median is the middle value. For example, 3, 7, and 5, n is 3. 3 is an odd number. Since 3 is an odd number, then we are saying the median is the middle value. We are simply saying the median will be given by the number at the center of these 3, which is 7. But when n is an even number, for example, if I had 3, 7, 15, and I add maybe another one like 20, that now becomes an even number. The median is the mean of the 2 middle numbers. So now you see the mean now will change, and it becomes the mean of the 2 middle numbers. That is what we're trying to describe there. So it is important to know n is the count of the numbers you are working with. If the numbers are 3, n is 3. If the numbers are 10, like you are taking 8 subjects in school, is 8 even or odd number?
Even number.
Even number. So it will follow this rule here now. Your median, after you arrange your marks in order of size, beginning with the small or beginning with the largest, either way, then the mean is the average. I mean, the median is the mean of the 2 numbers at the center there. Are we moving on well up to that point? Yes.
Yes.
Correct. Next slide. Let's look at an example here. Example 1. Obtain the median of the following data sets. So maybe before I display the answer, you can look at it and chat me the answer. What is the median of that data? Without wasting time, the data has been arranged in order of size. So you are not arranging again. You only need to ask yourself, is it odd or even? If it's an odd number, then you'll only get the median as just a single digit number, one of those numbers there. But if it's even, the median is not any of those numbers there. You have to work out the average of the number, the 2 numbers at the center. Wow, I can see so many people have sent the answers, and therefore we already now know the answer, as you can see there. So I can see answers. All these answers seem they are right. I think nobody has gotten. No. Median is 9, eh? Is it 9 or 7? Oh yeah, n is 7. Sorry. Yeah, you are right. Eh? It's the 4th position. 1, 2, 3, 4. The number in the 4th position becomes the median. So this is what you were saying. You first look at. Let me share. Let me annotate this. I'm saying you first count how many there are. You discover these numbers are 7. 7 is an odd number, and therefore the median must be one of those numbers. So you use the understanding that median is n plus 1 divided by 2 to give you the position. So in this case, it is the 4th value. So you just count 1, 2, 3, 4. And the 4th value in this case is 9. And 9 becomes the median of that data set. All right.
Yes.
Good. So moving forward. The median is 9, as you can see there. Another example, work out the median of that data set. I'm also assuming the data is arranged in order of size, so that one you don't need to struggle looking for the order. Give me the answers. Let me see your charts. First, ask yourself whether it's odd or even numbers. If they are odd, then you know. If they are even, then you know what to do. Odd numbers, the answer is found at one of those numbers. Even, you have now to do the calculation. Yes, Christian Madenge, Savia Ulu, the answers are coming. Arnold Usoro. This one seems like we are all getting the same answer. I'm not seeing any variation. James Omoke, you have the same answer as Tongwe. As no, Griffin, your answer is different. I can see Kisa, your answer is okay. Because it's just the introduction, before it becomes more complex, let's look at the answer here. And based on your presentations, the answer that we have n being 6. And when it's 6, it tells us this 6 is an even number. And therefore, the median cannot be any of those numbers. It must be the average or the mean of the numbers, and the two numbers at the center. And that's why now, when we look at the working, the answer now changes. Sorry, I'm trying to work out this. So the median occupies the 6th position, and the 6th position, as you can see, does not exist. So it becomes a median of 160 and 164. And you gave me the answer as 162. Those who answered, which is the correct answer. So I saw one person who got 161. I don't know how. Okay. Now find the median of those two numbers, 1 and 2. This is for your own working. Find the median of those two numbers. Of those two questions, not numbers. Just do both of them and chart the two answers at the same time, because it's a short thing. I can see 25, I can see 5, I can see 1, 5. I can see 28, I can see 4.5, 28 and 5. So the answers are varying. I can see 25, 4.5. I can see 28, 5. I can see 28. I can see 4.5. I can see 25, 4.5, 28, 5, 28, 5, 28, 5, 4.5, and the 25. Oh, so there are variations. So let's see. Why do we have these variations instead of having the same answer? But the answers that are appearing, most of them are 25 and the 5, then 28 and the 4.5. Those are the common answers. So let's see why the answers are not the same. So to answer this question, we look at number 1 first. And the first question is the data arranged in order of size?
Yes.
No, data is not arranged in order of size. So that becomes our first assignment. We first arrange. What's the lowest number? 20, followed by 23, followed by
25.
25, followed by
27.
27.
The last one is
28.
28. Now, I can see why people got it wrong. Most of you just went to the data the way it is and you say the median is 28. Those who are giving the answer as 28. And that is what happens in your exams, guys. You're always in a hurry to get answers wrong. We agreed, those who are there when we started, median is the middle value of the data as arranged in order of size, whether it's in ascending or descending. You are just getting the question and very quickly you start working out. Then you end up with wrong answers. Then we said, before you look at, you do it, ask yourself, are the numbers even or odd? So these numbers are odd. Since they are odd, the answer is found one of them. So those who gave me the answer as 25, you were right. So look at the next one. Is the data arranged in order of size in the next one?
No.
Let's arrange it. So we start with
2, 3, 4, 5, 8, 9.
4,
5,
5,
8, 9.
8, and 9. Now, when I was looking at that one, Some of you gave the answer as 5 and others gave the answer as 4.5. So let's see which one was right. Before we answer it, we first arranged in order of size. That is okay. Number 2, is it odd or even?
Even.
Is it even or odd?
Even.
Since it is even, then we say the median is found by the average of the two numbers at the center. So these are the two numbers at the center. So we work out their average by taking 4 plus 5 divided by 2, and the median was 4.5. So those who gave me 4.5, you are also wrong. You are also right, but there are people who gave me 5, which was wrong automatically. Do you see how you're always in a hurry to get answers wrong? Take your time before you answer a question and understand it. Okay. These were your solutions. These are the solutions for that problem. So let's look at the next one. We now look at what we call quartiles. Quartiles. We are through with the introduction of median. Let's look at quartiles. By definition, we say quartiles divide a data set into 4 equal parts. Remember, we said median divides the data set into 2 equal parts. Now we are moving away from median to quartiles. So under the way I illustrated the first one, in the median, I said if data was just arranged from 0 to 10, and we are looking at the median, we would have said the median is the number at the middle there. But now we are adding another understanding where we are saying we want to divide this data into 4 parts. So which means it's like now I have a half here and another half there. So if I add this data point
Exactly
here,
what we did.
sorry? If I take the data point in this position and the data point in that position, now I will be having quartiles. Quartiles. So quartiles divide a data set into 4 equal parts. If you look at this diagram now, there is this bit, there is this bit, there is this bit, and there is that bit. So there are 4 parts. If I do it in a clear way, if this is the quartiles, for this first quartile, second quartile, third quartile, and they have divided this data into 4 equal portions. That's why they are called quartiles. They divide a data set into 4 equal parts. So you can now write the notes after that, which says, here we have, sorry, where am I? I'm supposed to be here. There are 3 quartiles in total. Number 1, the lower quartile, and statistically we denote Q1, standing for the lower quartile. We have the middle quartile, which is also known as the median.
So we can't hear you.
Sorry, can you hear me now?
Yes.
I hope you got the other explanation I had before. I don't know whether I had muted.
You can repeat it.
The other one before, I had muted.
Didn't hear the upper quartile.
Oh, sorry. Let me go back there. I don't know how I muted. You know, I also had meeting some people because I interfered with my screen here. This is where I was, huh? Did you get this right?
Yes.
Yeah, we said Quartiles divide the data set into 4 equal parts. In total, there are 3 quartiles. Lower quartile, which is Q1, middle quartile, and as I'd already illustrated, whether that time I was audible, I'd said if you have a data set like this, the median is Q2, and the median divides the data set into 2 equal parts. But when I now look at this half and I divide it again to half, I get the first quartile. If I look at the upper half and I divide it again into another half, I get the upper quartile. So that's how we arrive at Q1, which is the lower quartile, Q2, which is the middle quartile, which is the same as the median, and then Q3, which is the upper quartile. And I already mentioned that if you look at the quartiles, they have divided the data, or they'll have divided the data set into 4 equal portions. Was that clear from my previous explanation?
Yes.
Good. All right, let's move on. So we had already moved on to the next slide, where I'll say, let's look at this. Example 3. In example 3, and I want you to look at this very keenly, because you usually, most of the students usually get it wrong at this point. Spare some minutes to be keen here and see the way I'm bringing it out. I'm sure you've done it before, but it's important you look at this. So I have 2 data sets here. There's that data set, which moves from 3, 5, 9, 11, 14, 17, 21, 27, 32, 41, and 43. How many data sets are those if you are to count? How many are they? 11. Is 11 odd or even?
Odd.
What is our rule? If the data numbers are odd,
Then the median.
A half.
the median is part of that data. The answer must be in that data already. If it's odd, our question is, how do we locate it? We ask ourselves, what is the center of those 11 numbers? So in this case, our center will be what?
17.
17, eh?
17, Mwalimu.
Yes, 17. Now, look at the next data set. How many data points are there? How many?
10.
10. Is 10 even or odd?
It is even.
Even. So the median is not there. So it is our now duty to calculate the median by asking ourselves, what are the 2 numbers at the center? And we use the 2 numbers at the center to find the median. So in the first case, there were 11 numbers. So we knew the answer must be there. And we located the center to be 17. In the next data set, there are 10. So the median is not there. So we have to use the 2 numbers in the middle and we work out their average. So what is the median for that number? Or rather, what is the Q2 for that data set 2? Sorry?
17.
It is also 17? Because we are taking 14 plus 21, eh? Am I right?
Yes.
Yeah.
But now remember, this 17 was not in the original data set. We are the ones who have created that 17 because the data set was even. But that is not my key point. My key point is, how now do we get to Q1 and the Q2? Read this statement. Can someone read this statement where I'm putting a star?
Q1 is the median of all the values before the median.
This is the key word. That's why I put it in bold. Before the median. It is the median of the values before the median. So look at data set 1. What was the median? 17? 17. So I now look at the numbers that are below the median. We don't use the median in the process of looking for Q1. So that's why this becomes our Q1. And now the other upper set is this one. This becomes our Q3. Look at the way I've not touched 17 to look for the upper quartile and the lower quartile. But some of you, when you are working out the Q1 and the Q3, you end up using 17. And you say the median is in between, is somewhere here, 9 and 11, which is wrong. That's why my slide reads Q1 is the median of the values before, just like Q3 is the median of the numbers after the median. In this case, you can see it does not matter whether I'm dealing with odd numbers or I'm dealing with even numbers. Q1 is the same for the two cases, because the number I created here, the 17 we created here, was our own creation. It was not part of the data set. So I still now say my quarter one is
15.5.
numbers below the median, which we created our own value of 17. So the core question of whether the data is odd or even now becomes irrelevant. It is only valid when you are looking for the median. Is it clear? I can see many charts. I don't know whether there are things I should be responding to. What is it? Oh, somebody says 17.5. Did we calculate correctly? Somebody says the median 14 plus 21 is what?
35.
Divide by 2?
17.5.
17.5.
Oh, good. So the median is 17.5 here. Thank you. I had not calculated. I was working with the numbers that you had mentioned. Correct. So the median in that case is 17.5. But when I'm looking for the upper quartile, now I don't deal with the 17.5. I deal with the numbers above the median or the numbers the median. And that is what I was trying now to stress on. Yes, I can see many people have already chatted about 17.5. I have not looked at your charts. So are we now getting it clear how to work out the quartiles and the medians with data that is not grouped?
Yes.
Good.
Yes.
Okay, let's move forward. Let me clear this. Now, there you are. Give me those answers. Obtain the quartiles in those two data sets, and you chat me your answers. This question 1, write Q1, then the answers for Q question 1, this question 2, so that I know the difference. Obtain the quartiles in those two cases. Yes, let me see what the answers I'm seeing. Yes, I've gotten an answer from Andrew. Andrew is the first one. Muyeku Matilo, I've not gotten your question. I mean your answer, but you've chatted something, Muyeku. I'm waiting for the answer, Matilo. Only Andrew has answered. Andrew has gotten the second one. Xavier, I've seen your answer. Yes, shortly, you'll do it. Do shortly in the next 3 minutes, please. Wakai, I've seen your answer for one question. Yes, at least Moyeko are now seeing you have two answer for the two questions. Wakahiu, yes. Absalem, Ibrahim Nyururu. And the answers are totally different. I don't know what's happening. Njenga, I've seen your answer. Griffins, I've seen your answer. And everybody seems to be getting their own different answer for reasons I may not know. Doria, I've seen your answers. Siad, I've seen your answer, Abdurizak. Okay, because now you are doing the question, as you do the questions, can we allow Mwalimu to take Rocco? Mr. Mbiru, are you around? Hello, Mr. Mbiru? Hello? I'm still following the answers as I wait for Mwalimu. Asaf Kibi, what? My question is, why are the answers different? Yeah, you can now take Rocco. Mwalimu, over to you. Rocco is going on. Rocco is going on. Please participate so that in the next few seconds we are done. Let's all participate. You are not moving. Let's take Rocco first. We'll continue with the question. Let's first finish Rocco. How many more to go? Only like 20 of you have not finished. Rocco, please. We had 90%, around 12 of you to go. No, 22. 20. Let's finish the Rocco. Alimu, I think, is not moving on up to, we are now 210, around 209, 227. 210, 70, now, good. I think that's okay. You can complete Mwalimu as I now work out the solution. Look at their solutions. Yes, Kiara, there we are. Alexander Umundi. These answers are very different. I don't. Okay, so let's see why the answers are varying so that we can now allow Mr. Mburu to move on to the next level. So we had said obtain the quartiles in this data. And we said the most important thing is first to discover where the median is. Once you discover the median, the answers become easy. So these are the answers for number one. I saw very different answers. Those are the answers. Q1, as you can see, the way I've labeled or I've tried to show the location, like this is where we expect the Q3, this is where we expect Q1, this one is already known. The idea is first locate the median, then look at the numbers above, find their median. Look at the numbers below, find their median. That is how you are supposed to work out number one. And number one, I saw guys writing 12, others writing 24. And the median, I think the median was right in most of your cases. I can still see more charts. I don't know it's for which question. Yeah, this is for question 2. Question 2, Doria. Yeah, I can see your answers for question 2, Doria. 150, 160, correct. So those were the answer for number 1. Let's look at number 2. What about number 2? Number 2, those were the answers. 152, 158.5, and 163. And that's how now we work out the median of ungrouped data. Any question? or any concern. If you don't want to shout, you can chat. I will respond to it as we finish. Mr. Mburu? Bwana Mburu? Hello? Yeah, Benjamin, you can see your last one is not correct. Benjamin, your last one is not correct. Yeah, I can see somebody telling me we do the question. Eh? Maybe it is wrong, I'm not sure. Yeah, somebody is saying we do this second question together. He's chatted me. And as we had just agreed, the first thing is to find how many numbers are these in total. These numbers, I think they are 8. So there is no median there. The median must be the middle of the two numbers. And that's why the median is given by 158 plus 159. And then you divide by 2. And as you can see, that becomes our Q2 here. This is our Q2 worked out there. Then we said, how do we get Q1? Q1 is given by, after now we identify the median here. You look at the numbers that are below here. How many are they? They are 4. So their median is also the median of these numbers as shown here. And that's why our Q1 is worked out here. The same, which numbers are above? These numbers are the ones above. And because they're also even, their median is a number here, which we don't know. That's why we took 162 plus 164 divided by 2. Mr. Mburu, for the quartiles, do you also arrange in ascending or descending order? Yes, yes. That's why I said you first look for the median. If the median is part of the working, then they must be arranged in order of either ascending or descending. Any other concern? You can chat. Bwana Mburu. Mr. Mburu. Yes, yes, I can see although what you're asking, but that is now what we want to do after we clarify with this. Now we go to that other one. I don't know whether Mr. Mburu has lost his network. We were together a few minutes ago. Bwana Mburu. Hello. Okay, somebody's asking a question here. Would you mind explaining again? Have you understood, guys, what we have discussed?
Yes.
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 Sorry? Anybody with a concern? Mr. Mburu is getting in shortly. We're just waiting for Mr. Mburu. Maybe somebody is saying, there's somebody who is chatting and saying he has not understood the same question. I don't know which part. This question and the other one, where are we getting lost? Those who are saying they have not understood. Let me see again, this one. Remember what I told you is what is key. I think I saw a chat from 2 people. So wait for Mr. Mburu. Look at these numbers. How many are they? Count them. How many are those numbers?
9.
They are 9. Is 9 even or odd?
Odd.
Odd.
So which tells us the median must be one of those numbers. And therefore it must be the center number. So this happens to be the center number. The moment I locate the median, I cancel it out. I forget about it when I want to get the quartiles. So it's like now that 19 is not there. I'm now looking at a new data set. This is what is left after I cancel the 19. So what's the median of those 4 numbers? That's why we are saying it must be the mean of these 2. And this is the calculation of Q1. 12 plus 13 divided by 2. Since as I'm just putting it, the moment I realize 19 is the median, I cancel it out and I forget about it. It is not there anymore. What is left below 19 is what I use to work out the lower quartile. What is left above 19 is what I use to work out the upper quartile. Mr. Mburu, are you back?
Yeah, I can hear you. My network had failed.
Okay,
No problem. I'm back.
I was just trying to build on the concept of location of the quartiles and the median using an sorry?
I'm saying I had followed that. My network just dropped for a minute. So we can proceed now with the group data.
Okay. Let me stop this share.
Okay.
Over to you, Malik.
Good morning.
Morning.
Good morning.
Okay, now that Mwalimu has done very well in introducing today's lesson, that is the median and the quartiles, especially with non-group data. So I'm going to just do some build up on what he has done, but now we focus on group data. I have some worked out examples here. Just a minute. I'll start with the first one, that is a median. I'm hopeful that you can view the screen.
Yes.
Okay, now we proceed. With group data, normally the data is already arranged in some order. Mwalimu did well when he did that whether we arrange them in ascending or descending is immaterial. However, with group data, we will notice that somehow the data is already put as per the class. That is to say, the first class there, 19 to 19, is somehow smaller than 20 to 29, which is smaller than 30 to 39 as you progress like that. So that we have the class 60 to 69 having the highest scores. So if we have some class, those who are scoring between 60 to 69 will definitely be having higher scores than those scoring between 50 to 59. And they will have a higher score than those between 40 to 49, like that. So we see our data already is in some order. And in most cases, group data, we have them arranged in ascending order. So that those with the least scores occupy the first positions. Those with the least scores occupy the first positions. So we did this in Form 2. So I believe we all recall what we did, but I will just make a review. When you want to get the mark at the center, that is the median mark. And remember, Mwalim said about position. So our focus is the center position. So stress on the one position we are interested in. That data is the group data table always gives you the data in order. So we look at the median class. That is the first thing that we should be concerned about, the median class. Now for non-group data, we are working with a single mark because the group the data is not grouped. But for this case, our data is grouped. So we have different classes for each marks. So marks are put into classes. So that tells you that median mark we are interested in will be in a certain class. It will be in a certain class. Now, for us to get the class, we need first of all to get the mark or the position, not the mark. We need to divide it by 2, and you divide by total frequency. If we have 50 students, we are interested in the center position. We are interested now in position 25. If we have 60 students and we're interested in the center position, the position will be 60 to so we take total free, which you are calling n, then you get position and the other end 2, we will get this position. We get yes.
Get new value.
Hello.
You're breaking, teacher.
Somebody.
Can't hear you.
Oh. Am I audible?
No, sir, you're still breaking.
Hello.
Hello, you're still breaking, sir.
Is it any better now?
Yes.
Okay. My network seems to be having issues, but hopefully we'll be able to sail through with minimal issues. Okay. We are saying that our interest is position. So we take total frequency, which I'm saying n, then we divide that by 2. Total frequency divided by 2. We are going to get the median position. We are going to get the position at the center because our data, like we've said, is already in some order. Now for this one, for group data, in most cases you'll be given mark, then you'll be given frequency. You'll be given a row for mark, then a row for frequency. Now it will be upon you now to try and come up with some order, or rather allocate positions. We do allocation of positions. Like in the first class, we have 3 items. So you award them position 1, position 2, and position 3. In the second class, we have 4 positions. Because position 1 up to 3 were already taken in the first class, you allocate them position 4, 5, 6, up to 7. We go to the third class, which has 30 to 39. We have 7 items there, and already 7 positions have already been occupied. So that tells you we are going to position 8. So the items in the class 30 to 39 take position 8 to position 14. Then we go to the next class, which has 15 items. So far, 14 positions have been occupied. So we go to position 15, 16, 17, all through up to 29, so that all these items in position in the class 40 to 49, they are awarded positions. Then we go to the next class with 11 items. So far, 29 positions have been taken. So we add the 11 here so that we end up with up to position 40. So the initial 1, 2, 3, 4, 5 classes have taken up to position 40. So the last class, which has 5 items, therefore will take position 41, 42, 43, 44, and 45. So that now everybody has a position. So that every mark now has a position. So we started with the first 3. We added 4, we added 7, we added 15, we added 11, we added 5. Now whatever we are adding is frequency. We are adding frequency. And we are adding it cumulatively. So we create a row for cumulative frequency. Now this row for cumulative frequency is the one that is going to give us positions. The row for cumulative frequency is the one that now awards marks their positions. So that if your mark was between 10 to 19, all of you will get position 1, position 2, position 3. Those that were in that category will be awarded position 1, position 2, position 3. So that now the next bunch, where we had 4 students, the frequency was 4. They take position 4, 5, 6, and 7. So we go all through up to position 45. Now our class of interest, or rather our position of interest, was the position at the center. So we say we had 45 students. So position at the center will be n over 2, which will give us 22.5. So 22.5 becomes our position of interest. Just a minute.
Only we are breaking.
Can you hear me?
Yes.
Okay. So our position of interest becomes position 25. So what we do from there is to look for a class that will have that position 22.5. We look for that class that will be having that position 22.5. So we go back and say position 1 to 3, the first class. Position 4, 5, 6, and 7, the second class. Position 8 up to 14, the third class. Position 15, 16, 17, up to 29, the fourth class. And remember, our position of interest is position 22.5. So definitely, that position 22.5 will be in this class of 40 to 49. So we call that the median class. We call that the median class. Then we go now to our formula. Our formula states that for you to get the median of any group data, you get the lower class boundary of the median class, lower class boundary of the median class. Then we add our position. Our position was n/2. Then we minus cumulative frequency of the classes just before the median class. Then we divide that by the frequency of the class. Then we multiply by the weight of the class. So you should be able to memorize that formula. We've said it is the lower class boundary of the median. Our position, then we minus cumulative frequency of the classes just before the median class, then the frequency of the median class, then we multiply by the class weight. So what are we trying to do here? We want to get this position 22.5. And as we get that position 22.5, we want to get the mark that will be at position 22.5. We want to get that mark that will be at position 22.5. So we've all agreed that the position 22.5 is in this class I have circled there in red. So that is the mark that is there. And remember, the marks were arranged. We started with 10 to 19, 20 to 29, 30 to 39. Now we are in the class 40 to 49. Just before we got into this class, we had a class 39. From 10 to 39, we've already catered for those marks. Remember, the marks are progressive. We started with the least marks. We go on like that, we go on like that. Now we want to get the mark that will be in position 25. And the first three classes, the marks are progressive. So we keep on progressing. So as we are entering into this class, where we now have the mark, we need to know where do we start. So we start from our boundary, lower class boundary. So that is where our boundary is, L. And what is the lower class boundary? I think we've done this in the previous classes. What will be the lower class boundary for that class?
39.5.
Yeah, 39.5. So with respect to the class of interest, that is the median class, we start at the mark 39.5. We start at the mark 39.5. And we can see that the class ends at 49.5. It ends at 49.5. However, we cannot take the whole class, because if we were to take the whole class, it will take us to position 29.
Excuse me, teacher.
And
Why is there?
remember, that is not we are specific to the position. Hello?
I've started breaking.
How? Let me see if I can readjust my network. Is it any better?
Yes.
Okay. So I was saying, we are not going to take every mark from this class because it is ending at 49.5. So we look for a specific mark that was our median mark, our median position, which is 22.5. So we are not going to take everything up to the 29. Rather, we are going to take up to 22.5, which is somewhere in between the 40th and the 49th mark. Now, how do we get the specific point? How do we get the specific point? This 39.5 was for the boundary where we are starting from. And with this boundary, we've already catered for some positions, 3, 7, 14. We've already catered for 3, 7, and 14. And we are going up to 22.5. So how many items are we going to take from this class? So we say we are interested in position 22.5, and we've already so far catered for 14 positions. So we get that difference. So what is the difference there? 22.5 minus 14? 8.5. So from this class, we are only going to take 8.5 positions, not everything, not the 15 of them. We are only going to take 8.5 positions. And that is why we have this numerator here, n over 2 minus CF. So that we say, how many items are we going to take from that class so that we end up at our position 22.5. So we've seen that we're going to take around 8.5. It is now 8.5 out of how many? They were 15. So it is the 8.5 out of possible 15. Then we multiply that by the class weight. So what is our class weight? Our class weight is set because we say 49.5, we less 39.5. So basically, that is how you get to the median mark, 39.5, because that is where our class is beginning, our class that has the median position. Then we say, how many items are we going to take from that class? So we take the position of interest, then we minus the position so far occupied, then we say divide by the frequency of that class. So it is 8.5 items from the specific class that will lead us to position 22.5. Because from the previous 3 classes, we have 14 positions so far catered for. So from 14 up to 22.5, how many positions are we interested in? That's why we have this numerator here, 25.5 less 14. Then we say out of the number of students or the frequency for that class, then we multiply by the class weight, so that we eventually have 39.5 plus the quotient you will get here multiplied by 10, we end up with 45.17. So the 45.17, the interpretation is, if you had that mark, 45.17, you will be position 22.5, which is the center of that data. The center of that data.
Excuse me, teacher.
Yes.
Why is the center 22.5 and not 23?
Now, there was a time we were doing n over 2 plus, then we do some average like we were doing in group data. But nowadays they have changed to just n over 2. So if you say the 2 center position, then you get the average. We will notice that the difference is not that huge for grouped data. For group data, the difference is not huge. So we just focus on n over 2. If you are to take the 2 central ones, then you do the averages like we did in group data, still be correct, but the difference is not as huge. So we just focus on n over 2. Yes, we maintain n over 2. Unless, Mr. Mbithi, there is any other view? Mr. Mbithi? Okay. So what we do, we just focus on n over 2 and not like for the non-group data. We focus on n over 2. Because if you are to do the averages of the 2, like I have said, the difference is very slight. So just do n over 2. Initially, there was that doing the average of the 2 centers, then, especially when the n is odd. When n is odd, we were looking for the 2, then we divide by 2. But nowadays, they just say n over 2. That's okay?
Yes.
Okay, now let's proceed. Just a minute. Now, Mr. Mbithi had also mentioned about quartiles. Now, I want us to look at lower quartile. We now focus on lower quartile. The procedure is almost the same as the one for median. The procedure is almost the same as the one for median. Remember, our interest is looking for a certain position. Lower quartile will be the quarter part of the data. Remember, the median was the half part of the data. So lower quartile would mean that you're looking for the first quarter. So our total data was 45. I'm using the previous example. So if you want to get the lower quartile, you will say it is almost the same formula, but you notice that in our position, we have n/4 because we are interested in the first quarter. So we take class boundary, and for now, for this one, it is the lower class boundary of the class with the first quarter. It is the lower class boundary of the class with the first quarter, or Q1. And we take our position n/4. We are saying n/4 because we want a quarter. We want the first quarter. Our n was 45. So the first quarter will be 45/4, which is about 11.25. So 11.25 is the position Q1. 11.25 is the position Q1. Remember, 45 is the last position. So 11.5 will be the position at the center. Then again, we minus cumulative frequency of the classes just before the Q1 class. Cumulative frequency of the classes just before the Q1 class. Then we say over F. F being the frequency of the class with the Q1. So in some way, it resembles the one for median, but now we are focusing on the class with the Q1. So everything else revolves around that class with Q1. So we take lower class boundary of the Q1 position itself, that is n/4, minus cumulative frequency of the classes just before Q1 over frequency of the class with the Q1. Then we multiply by the weight of the class with Q1. So I had worked this out. So it was 45. 45 was my n because I had a total of 45 students. So n/4. Over 4 now, the previous one was over 2 because we are looking for the median. But now we do over 4 because our interest is a quarter. We want to get a quarter. Quartile means a quarter. So the quarter position will be 11.25. That is the quarter position. So the Q1 class is a class between 30 to 39. I don't know whether you still have access to the previous table, but it will be the class between 30 to 39. The class between 30 to 39 as per the cumulative frequency. Remember, we had some cumulative frequency somewhere. So the class with 11.25, as per the cumulative frequency column or row, it will be the class between 30 to 39. So again, we circle that class 30 to 39. We circle that class 30 to 39 because everything in this formula revolves around the class 30 to 39, the class with Q1 mark. So again, lower class boundary of the class, the lower class boundary will be 29.5. Then we add the position that we want, Q1, which is 11.25. We minus the position so far occupied. Before we went to this class, how many positions have we so far occupied? So cumulative frequency of the classes just before the Q1 class. So far, how many classes, how many positions have we occupied? So we get, in the numerator, we get the number of items we are going to take from this class so that we end up at 11.25. And maybe somebody, what is 11.25 less 7?
4.25.
So 4.25. So we will only take 4.25 from this class. The moment we take 4.25 from this class, we will end up at 11.25. So that means we will not take the 7 of them. I believe the class had 7 items. So we are not going to take 7 of them. We only take 4.25 so that we don't go to the upper boundary. We are only interested in 4.45 so that we end up at the position 11.25. So this numerator here tells you how many items we are going to take from this class so that we go to the position 11.25. Then we divide that by how many were they in that class. How many were they in that class? Then we multiply by the class weight so that eventually we get 35.57. So everything resembles the median formula, only that now our position changes. We are no longer talking about n over 2. We talk about n over 4 because we want to divide our data into 4 equal parts. Then we get the first quarter. The first section, when we divide the data into 4, the first quarter will be n over 4. I hope that is clear.
Yes.
Okay, now let's look at the last one. That is the Q3. Q3 now will be the other end, the quarter 3. Remember, quarter 1 ni position ya the first quarter. Quarter 2 ni median. 2 quarters means half. So quarter 2 ni median. Now quarter 3 will be the quarter just after the median. Quarter 3 will be the quarter after the median. So we are interested in the 3 over 4 of the whole data. The third quarter, sometimes called upper quartile, the third quarter. So the formula is still almost the same. It is similar, only that now we change the position. The position, we say it is 3n, 3 times total frequency over 4. Then we minus CF over F times I, just with the same thing that we did with the median and Q1 or the lower quartile. The only different thing is that we are talking about 3 over 4 of the whole data. 3 over 4 because we're interested in the upper quartile. We are interested in the upper quartile. I'm a Q3. Okay, so the thing that we look for first is the position. If we have 45 items and we want the position 3 over 4, so we just say 3 times n, our n in this case is 45, then we divide that by 4. So our position of interest will be position 33.75. Our position of interest will be position 33.75. Then again, we look at the row with cumulative frequency because that row of cumulative frequency is giving us positions. And from my data, my 33.75 was in the class 50 to 59. You can confirm. My class with that position was the class 50 to 59. So I will again circle the class 50 to 59 because that will be my class of interest, because everything here is talking about this class 50 to 59, the class with the Q3 mark. The class with the Q3 mark is the class 50 to 59. And everything in this formula is talking about this class. It is the lower class boundary of this class. 3n over 4 is the actual position which is in this class. CF is the cumulative frequency of the classes just before this class. F is the frequency of this class. Then I is the weight of this class. So the class 50 to 59 become now my point of focus. So if you are to follow again the cumulative frequency, by the time we are going to our class, we will have taken about 29 positions before we went to our class. And these 29 positions will make it possible for us now to go to the 50 to 59 class. So where do we start? We start from the boundary, because for the 29 positions, we've already catered for the 49.5 marks. That's where we are beginning when we are entering our class of interest. That's why we normally start with the lower class boundary. That's where our beginning point with respect to this class. Then we are not going to take the 11 students, all of them from that class. Instead, we are going to take some of them. And by some of them, we say, so far, how many positions have we allocated? 29. What is the position that we want from this class? 33.75. So what is the difference here? Somebody? What is the difference?
$4.75.
So 4.75 is the positions that we are going to extract from 50 to 59. We don't extract everything. We only extract 4.75. Those are the number of students we will take from this class, not all of them. So that's why we are saying the position of interest minus the position so far occupied, so that we see how many students are we going to take from this class. And it was 4.75 out of 11 students, because in that class, the frequency was 11. Then we multiply that by 10, so that eventually we'll have our Q3 as 53.82. We have our Q3 at 53.82. I hope that is clear.
Yes.
Okay, now for your
Yes.
for your takeaway assignment, maybe you can write this. We start with 10 to 19. 10 to 19, we have 2. So you can say 10 to 19, we have 2. I want you to calculate Q1, Q2, and we say that Q2 is a median, and maybe Q3. Q1, Q2, and Q3. So the data I'm giving you is 10 to 19. 10 to 19, we had 2. So the frequency is 2. Then we have 20 to 29. We have 20 to 29. We have a frequency of 3. Then the next class, we have 30 to 39. Frequency 7. Then you have 40 through 49. 40 through 49. Frequency 15. 50 through 59. Frequency 11. Then the next class, 60 through 69. Frequency 4. Then you can have the last one, 70 through 79. 70 through 79. Frequency 2. So your assignment is to calculate Q1, Q2, and Q3 for that set of group data. Maybe I can repeat it very fast.
For 70 to 79.
70 to 79, we have 2. Maybe I can repeat it very fast. 10 to 19, frequency is 2. 10 to 19, frequency is 2. 20 to 29, the frequency is 3. 20 to 29, frequency is 3. 30 to 39, frequency 7. 40 to 49, frequency 15. Then 50 to 59, frequency 11. 60 to 69, frequency 4. Then 70 to 79, frequency 2. I hope all of us have gotten it correct.
Excuse me.
Yes.
Could you project?
Yes.
Could you project the table that you used to do the examples you've shown us?
Yes.
Could you project the first table that you used to do the examples?
Okay. True. I remember that I just extracted the working. I forgot to give you the table, especially for Q1. That's the table you're talking about?
Yes. Thank you.
Yes. So for this specific table, our Q1 was what position? 11.25? Was it 11.25?
Yes.
It was 45 over 4. 45 over 4 was 11.25. So that's why we took the class 30 to 39. Thank you for bringing us here. That's why we took 30 to 30, because it was 45 over 4. Then the next one was 45 over 3. Not over 3. Times 3 or 4. 40 over 3. The position. What position are you getting? It was 33.75. So 33.75, that's why we took this class here, because this class had 29. So that means position 30 was in this class. Position 30, 31, 32, up to position 40 was in that class. So that's why we took this as our Q3 class. We took this one here as our Q1 class. Then the formula is L plus, then you change this. If it's Q1 N over 4 minus C class over N times Q1. If it's Q2, CF median plus Q3 N 3N over 4 to give minus CF of the class 4, then over frequency of. I hope if there are no concerns, we end there. Thank you again for your availability. We see each other tomorrow, maybe for the final part of statistics. Thank you very much.
Thank you for the lesson.
Thank you, sir.
Thank you for the lesson. Thank you, sir.
Asante mwalimu.
Thank you.
Thank you for the lesson. Thank you for the lesson. Well done.
Thank you for the
Thank you, Mwalimu.
Akelu. Joust.
Thanks.
Kirai.
IG yako Akelu.
Ati? Hii stuff bado iko
IG
on.
yako.